Hi! This video we're going to be talking about faster than light travel, or different ways to travel around the universe that we see in science fiction, and which ones work, which ones are difficult, which ones can never happen. I do recommend that you watch the space-time video that I have to try to give you some background, because I'm going to be referring to that a lot. In short, if that sounds familiar, what I'm going to be talking about is that whole concept of the bowling ball and the trampoline for how gravity works and how our universe is shaped. So when we talk about traveling through the universe, we need to consider how long it's going to take us to get somewhere. And we have some technologies that we use today. We do gravitational slingshots or ion engines, but those are slow. There's limitations to how fast we can go. Even Voyager has been traveling out of the solar system for the last 40 years, and it's only just left. So we need to try to find different ways to travel. Now, if we get better and better technologies, we're still going to be limited to the speed of light. The speed of light is the fastest anything can move. And that's because our universe has this sort of trampoline shape, this space-time. And if you have any mass, you're going to bend that space-time a little bit that limits how fast you can go. Now, light particles don't have any mass, so they travel in a straight line. They don't make any dent in that trampoline, they just travel on the surface. That's the fastest anything can go. It's 3 times 10 to the 8 meters per second. Now, that might not seem like anything to you, because big numbers. But another way to think about it is the light that it takes to get from the sun to us actually takes 8 minutes. So when we look up at the sun, not directly of course, but when we have light from the sun reaching us, it's taken 8 minutes to get there. So that's actually the light that left 8 minutes ago. So the universe is big, space is big, our solar system is big. There's a great video I can recommend called If the Moon Were a Pixel, and you just try to travel through space and it gets really boring really fast, just traveling through our solar system. Even if we get technology good enough to get close to the speed of light, even getting to the nearest star system is gonna be over 4 years to just get there. So that's not great. We need to come up with a more exciting, more fun way to see the universe. So different science fiction comes up with different methods of faster than light travel. They typically use all about the same 3 types of methods, one of the 3 or a combination of those. So I'm gonna go through each one of those. The first one that we see a lot is wormholes or jump gates. It's the same concept. Basically one is kind of natural and then the other one's artificial, but that's the whole idea that you go from a point to another point. And the way that this works is that you can imagine our universe is that weird trampoline, but it could be shaped however. One of the ways I like to think about it is if you crumple up toilet paper, and it's not lovely, but crumple up toilet paper and then kind of flatten it out, not all the way, but just stretch it out, it's gonna have little ridges and flows and things like that. You can imagine our universe maybe being shaped like that. And there could be a possibility where traveling on the surface takes you a long time, but you could punch straight through and you would be going from one point to another a lot faster. And that's basically the concept behind wormholes. Now, there's nothing saying that they can't exist, but we've never seen any possible evidence of them. Essentially, they would be shaped in the same way like a black hole, they just come out on the other side. But this is used in science fiction all the time. You can think of the wormhole from Deep Space Nine, Star Trek Deep Space Nine, where it opens up and you can travel through, and that's kind of a natural wormhole. And you can also think of mass relays in Mass Effect are kind of the same way. They go from a point to a point. Or stargates, jump gates, go from one point to another. And they're totally fixed, and they're always going to come out at the same point. Now remember space and time, space-time. So you could have time elements go into there, but that starts to get confusing. We're just going to be talking about traveling distances right now. So wormholes, jump gates, that's one way that you can travel through. Again, artificial or natural, they just go from a point to a point. The next one is called a jump drive. So the one that we see this the most is Battlestar Galactica, which is pretty cool. They actually do it really well. But that's the idea that you want to travel from this point to this point, and instead of there being a shortcut already, what you do is you bend space toward you, make the jump, and then let it unfold. And then you're over at this point. This is tricky. They're all tricky. But this is tricky because in order to bend space to you, you're going to require a huge amount of energy. So remember, E equals mc squared, energy and mass are equivalent. Mass bends space-time. If you don't have enough mass to bend space-time, you could theoretically get enough energy to bend space-time, but it's going to be a lot. Because remember, we're multiplying it by the speed of light squared, so it's a big, big number that you need. But one of the things that I do like in Battlestar Galactica is they actually implement this to some extent. So they have to take time to spool up their jump drive. Remember, they spool up the FTL drives. And you can think of that, what that's doing is bending the space to them when they're spooling up their FTL jump, and then they jump, and then it unbends. They also kind of do a good job of referencing beyond the red line. So this is the idea that you have sort of a map of your universe and where you want to go, or your galaxy or star system, whatever you're doing, and you know what it looks like. So you're bending a known point in space to you, making that jump and then unbending. When they refer to beyond the red line in Battlestar Galactica, that means it's beyond what they've been able to map. They've not seen that part of the star system, galaxy, whatever then. So the last type of faster than light travel that we see a lot of is warp drive, or warp bubbles, or hyperdrive, all kind of referring to the same concept. And this has nothing to do with sort of shortcuts through space. What you're doing is you're finding a loophole in the laws of physics, in that nothing can travel on the surface of space-time faster than the speed of light, but nothing says that space-time can't travel faster than the speed of light. So what you do is, instead of trying to travel along the surface, you're going to constantly be building these layers, or this bubble around you, that's going to allow you to propel yourself through space-time a lot faster. So you aren't violating the laws of physics, because nothing says space-time itself can't travel faster than the speed of light, or a bubble within space-time. That's not really found in the laws of general relativity, which is kind of cool. So going into this a little bit more, obviously Star Trek uses warp drives the most. That's what most people think of. And they all kind of come up with arbitrary rules, which I really like, because you could just say, yeah, it works. And Star Wars kind of does that. Star Wars just says, it's a hyperdrive. We're just going at a speed. And that's fine. We're not going to think about it that much. But with Star Trek, obviously it's been around a lot longer, there's a lot more content for it, and so they do come up with a lot more of the science. You know, they have warp factor 1, 2, 3, 4, and on. Not beyond 10, because terrible episodes happen when we go beyond warp 10. But the way that this works is that you bend a little bubble around you, and that propels you one. But then you can imagine if you do that within another bubble, you could go even faster. And then that within another bubble, you go even faster than that. And so this is kind of each warp factor is adding in more and more layers like an onion that will allow you to go faster and faster and faster up to a certain limit. So just to recap, we have these three types of faster than light travel. The first one is the wormholes, or the jump gates. These are fixed points in space-time that allow you to shortcut through, so you don't travel on the surface, you just punch straight through. They're fixed, they can be natural or artificial, and we see a lot of these. There's also jump drives, and that's the one where you're bending space to you, making the jump and then letting it unbend. And then the last one is the warp drive, or the hyperdrive, and that's where your ship manipulates space-time around you so you can actually travel faster than the speed of light, because you're pushing space-time faster than the speed of light. And you're not breaking any laws of physics that way. So all pretty cool. How can we get there? Because remember, if I'm ever going to join Starfleet, we need to get warp drive. So Zephram Cochrane's, as far as we know, is not around. So we've got to get on that, because I want to join Starfleet and meet the Vulcans. So how close are we? Not very. Scientists originally came up with a concept for a warp bubble. It's called the Albuquerque drive, and it's a similar concept. Your bubble is made up of constricted space-time in the front, extended space-time in the back. Same concept to how the warp drive in Star Trek works. Originally, when they came up with this concept, they tried to calculate all the energy that would be required to bend space-time in such a way, and the result was all of the energy, all of it, which isn't very useful. But now they've worked it down to about the equivalent energy of a semi-truck, which is good. Still scary, because remember, the nuclear bomb was the energy equivalent of a teaspoon of matter. So with a semi-truck, that's a lot of energy. But the cool thing is that now that we've discovered gravitational waves, I've got to do a shout out for that, because that's what I did my research in. But once we discovered gravitational waves, that was actually the first time that we've directly detected space-time. And so now that we've detected it, maybe we can learn to play with it. So that could result in improving our technology and actually getting warp drive. One would hope. So anyway, I hope you enjoyed that overview. As always, hit me up if you have any questions, and I'll catch you next time.